Welcome to the second video in the series of learning LLM. In the last session, we discussed the roadmap of learning LLM and we discussed why LLM is necessary for everyone. So basically, we understood two key concepts in the last session, which was the first session of this series. One is why LLM is necessary for everyone, and the second, what is the correct way, the right blueprint to understand it. But now the question is, what is LLM? What is LLM? Let's define it. Let's define LLM. And this is necessary specifically for managers, for project managers, because you need to first define what is LLM, what is machine learning, what is AI. You need to know what it means, what are the differences. Otherwise, it is very difficult for you to communicate with your team members or anyone who is working on any project related to LLMs or machine learning or AI system. Okay, so what is LLM? Let's define it. The general definition says a large language model is an AI system or AI model that is trained on a very large amount of text so that it can understand, summarize, and most importantly, predict text in a human like way. Here, text is very important. The foundation is text. And the second important word is it's human like. The prediction should be human-like. That is important. And that is a definition of large language model. You may say, yes, this is intuitive. We already know this. Perfect. But a few things you should remember. First, these AI models do not, do not truly understand your text. They only try to predict using probabilities and patterns. There is a misconception that these AI model, like for ChatGPT or GPT, understand what you're saying. GPT does not understand like human. Whether you like the statement or not, whether you have a different opinion or not, it doesn't matter. It predicts based on probability and the patterns. Okay. So for example, there is a bottle and there are multiple words like cat, bat, human, man, woman. So there would be probability associated to each word. What GPT or AI model or a large language model does is it just throws you the word, the next word, which has the highest probability. So it learns from pattern. It tried to predict the next word. I'm saying next word, but actually in the real term, it is token. What is token? For this lecture, please understand token is equal to word. When we discuss the lecture tokenization, we'll understand what is token and how we generate tokens. Okay. Now it also says it can answer questions, write text, translate, code, summarize, and more. But in reality, the first architecture which was designed for LLM was meant only for translation, was meant only for translation, and it was from English to German and English to French. The 2017 paper, Attention is All You Need, that is the paper. You can also Google it. It talks about translation. Just read the abstract of this paper and you will understand that. And the last, it doesn't think and no, it works from the patterns and probability. Okay. So what is LLM? We said LLMs are trained on large amount of data. Now the question is how large? How large this data to be? So the data is actually in billions. The data is in billion. Even GPT-3, forget about GPT-4 or 5, was trained on billions and billions of tokens, billions and billions of data. It has taken data from Wikipedia, multiple books, Common Crawl, web text, right? From this text, the model were being trained to predict the next token or next word. So it is trained on a large amount of data. But this large doesn't stand for in the large language model, in the large language model, this large doesn't stands for data. The large stands for large parameters. What? Large parameters. If you know a basic of machine learning or statistics, Let's try to develop an analogy. So there is regression. In regression, we try to predict y with the help of different parameters like y is equal to beta naught plus b1 x1 plus b2 x2 plus b2 x2 plus b3 x3, right? So in a model, these are the parameters. The beta values are the parameters, and x1, x2, x3s are independent variables which are trying to predict y. For example, x1 could be GDP, x2 could be interest rate, x3 could be inflation, and y is the stock price that you're trying to predict. So these parameters in the models are in billions. In normal financial or risk model, we may have 50 to 60 parameters maximum, but these LLMs have billions parameters, even close to trillion. This is a snippet taken from GPT-3 paper. You can see that the GPT-3 is is GPT-3 has 175 billion parameters to predict the next token, to predict the next word. So large does not mean large data. The large means large number of parameter. Now, what about language model? So in the large language model, we understood what large means. What about language model? Language mean it is trained on a large amount of text to predict the next text. That's it. So this is the definition, as in a very high level definition of large language model. Now, what is the architecture behind the large language model? So all popular large language models are nothing but neural network. And specifically, they are deep neural network. They are deep neural network. But what is the difference between a neural network and a deep neural network? First, let's understand neural network. So a neural network has three layers. One is the input layer. So these are the input layers. It will have output layers. But the most important layer is the hidden layer, which is actually the neurons of this neural network brain. If you think neural network is a brain, the actual computation happens in this hidden layer. Okay, let's understand with one example. So you input value x1 is equal to 2, x2 is equal to 1. And in the neuron, which is the hidden layer, there is a calculation which is going on, which is w1 x1 plus w2 x2 plus beta, where beta is a constant, w1 and w2 are the weight, which are 3 and 4. And this is doing a calculation and then throwing an output 8. So all the calculation happens in the hidden layer of a neural network, and that's why generally it is called the brain of the neural network. Now, what is the difference between a neural network and a deep neural network? A neural network will have one hidden layer. A deep neural network will have multiple hidden layers. So you can say that it has multiple hidden layers. So this is a deep neural network architecture. So all large language model has an architecture of a deep neural network, and they are being trained on large data set. And what this hidden layer does is it calculates the right weight to predict the output. Okay. So that is the high level architecture of the large language model. So large language model is what is a deep neural network, which is trained on a large amount of data, large amount of text. Perfect. So we understood a high level architecture of large language model, but the problem is, the problem is you should not confuse with the neural network and large language model. You should not be using them synonymously. Not all neural networks are large language model. Only those neural network and specifically deep neural network which are trained on large data set of human-like text are the large language model. However, even you cannot say that every deep neural network which is trained on a large amount of data set is a large language model. The reason is every neural network can do a specific task. Like it can do sentiment analysis. One neural network can do sentiment analysis. One neural network can do classification. One neural network can do questioning and answering. But large language model can perform all the tasks simultaneously. However, the large language models were designed only to do translation, but later on, surprisingly, they were able to do other tasks. So that is a very slight distinction that you should remember between just a neural network and a large language model. However, you also need to understand the difference between what is AI, how it is different from ML, how it is different from the neural network, what neural network you can call as like large language model. Okay, so at a very high level, if I say that artificial intelligence is the biggest umbrella. In this umbrella, there are different system, AI system or intelligent system. One system is like rule-based AI. So if you have like encountered some chatbots, those chatbots are rule-based chatbots. So rule-based AI. There are searching and planning AI. If you have uh, played Go with AI or chess with AI, those are based on searching and planning AI. And those are called as searching and planning AI. And then comes the machine learning. Okay. Now in machine learning, you can separate the machine learning or you can categorize the machine learning in two ways. Earlier, it used to be like supervised and unsupervised. So for the timing, I'm just separating it like traditional machine learning and deep learning. Now, traditional machine learning has regression, logistic regression, decision tree, random forest, SVM, KNN, K-mean, naive Bayes, everything. Now, in deep learning, I'm talking about deep neural networks. And in deep neural network, you can have different architecture. Now, this is important. This is a real stuff. This is a real meat. Now, in deep neural network, you can have different architectures like CNN, RNN, transformer, autoencoders, and GANs. Now, I have highlighted transformer and have written large language model. The reason I have written this because the 2017 paper, which I'm trying to highlight again and again, which changed everything in AI space, changed everything in the large language model, and on which all the new AI models or the large language models are based, that architecture was transformer. That paper discussed the neural network architecture, and that architecture was transformer. That was a game-changing architecture for large language model. So today, whatever the different kind of popular large language model that you know, whether it is GPT, Gemini, BERT, whatever it is, they are transformer based model. The architecture behind them is transformer. So transformers. Now someone will say that, hey, even CNN can also be used for language, large language models, and it can be a large language model. That is correct. But right now, CNN are best for image recognition, vision, and transformers are best for LLMs. Not saying that in future CNN or RNN or autoencoder or GANs cannot be used for LLMs. They can be. But right now, all the LLMs that you are using, the popular LLMs, are nothing but transformer deep neural network architecture. One most important thing that we should understand that how most LLMs are being trained. So most LLMs are trained using next token prediction. They predict next token, then the next token, then the next token. For example, if there is a sentence, the sentence is this is a. The LLM tries to predict the next word or next token. That's it. Then again, the next one. And this is the way the LLM work. Specifically, GPT works like this. Other model like BERT predict missing word in both the direction, and that's why they are called bidirectional. But GPT predicts left to right. So all LLMs try to predict text, right, left, or bidirectional, but always text and always driven by probability. Okay. So we discuss the definition of LLM. What is LLM? We discuss the architectural design behind LLM. We discuss what is the difference between AI, ML, and LLM. We discuss that how LLM work. So with that, we'll pause here. In the second video, which is critical, as I've highlighted here, we'll discuss transformers because the transformers are the backbone of LLM. So lecture 3 is about transformers. So we'll pause here. Thank you. Have a nice day.